Today, I'm going to show you how the Databricks Data Science Agent can build end-to-end predictive ML models from the raw tables all the way to business insights without leaving Databricks. Sure, there are plenty of great agentic code assistants out there, like Cursor, Claude Code, Kiro, and others. They're powerful, but they all live outside your data platform. That means extra licenses, extra integrations, and sometimes extra risk. This agent is native to Databricks. It runs inside your existing workspace against your governed data using your compute. No separate product, no context switching, and it respects your Unity Catalog permissions out of the box. In this video, we're going to watch the agent create and manage a schema and tables in Unity Catalog, generate synthetic but realistic customer data, run exploratory data analysis with plots and summaries, build features in ML-ready pipelines, train 3 predictive models, churn, sales forecasting, and fraud detection, and finally compare those models and translate them into business value. The big idea? This turns every data practitioner and even motivated analysts into kind of a citizen data scientist. You don't have to write every line of code yourself, but you stay in control of the logic, the quality, and the business decisions. Let's start at the very beginning. No tables, no data, just a catalog. I'm in Databricks in a standard notebook. On the right-hand side, you'll see the assistant panel with the data science agent enabled. I'm going to give it a natural language instruction to create a new schema in my catalog, add a comment explaining that the schema is for predictive ML demos, and confirm that the schema exists. The agent generates the SQL for me, runs it, and shows the schema description. I get that this is boring, but important work. Schema creation, catalog hygiene, consistent naming. The agent handles the boilerplate so data teams can focus on what actually moves the needle. Next, I'll ask the agent to generate synthetic B2B SaaS style customer data and write it into a Unity Catalog table. I describe what I want in business terms: 10,000 customers with 10-year monthly charges, contract types, paperless billing, senior status, and so on. I ask it to correlate these fields so churn, sales, and fraud behave realistically. The agent responds with a plan. It uses Spark to generate the data, write it as a delta table called demo ML, then show the first few rows. I approve the plan, it runs, and we now have a governed delta table that looks like data you'd get from a real SaaS business. The technical value here? I didn't have to handwrite the PySpark or data generation logic. And the business value? I can prototype models and use cases quickly, even before real production data is wired in. Now we treat this as if it were a fresh dataset we just landed from production, and I ask the agent, explore this table, show me schema, summary stats, churn rate, sales distribution, fraud rates, and a few key charts like churn by contract type, sales versus tenure, and fraud by transaction count. The agent writes the Spark or Pandas code, runs a describe on the key columns, calculates overall churn percentage and fraud rate, and generates a couple of visualizations. On screen, you can see churn is higher in month-to-month contracts, sales grew with tenure but plateau, fraud is very rare but more common with high transaction counts. The business value here, a data scientist or analyst can go from what's in this table to understand the basic story of the customer base in minutes without manually wiring up every chart. Now, as a limitation, the agent only sees what's in the table. It doesn't know your business context unless you tell it. It might miss a segment or metric that you care about deeply, so human judgment still matters. Now we're ready to build an ML-ready feature table. I ask the agent to clean the data or nulls for obvious outliers, create engineered features like tenure buckets and so on, and write those out as a new silver table in the same schema. The agent proposes a pipeline, generates and runs all the code. We now have a curated feature table that every model can reuse. Technical value? This is cross-cutting work that's usually tedious. The agent does it consistently and keeps it in the same governed environment. Okay, the first predictive use case, churn prediction. I ask the agent to use the feature table, build a classification model to predict whether a customer will churn, split the data into train and test, train something reasonable like a random forest or gradient boosting model, and report metrics like accuracy, precision and recall, AUC, plus feature importance. The agent writes and runs the code. We see performance metrics and a ranking of important features. The business value is this gives customer success and sales a prioritized churn risk list almost immediately. You can imagine using this to drive targeted retention campaigns. Second use case, sales forecasting. Now I ask the agent, using the same feature table, build a regression model to predict each customer's monthly sales. Use the same kind of train test split and show error metrics. Also plot actual versus predicted. This kind of model is used to plan revenue, define targets for account managers, or identify customers whose sales are below potential. The business value is that you're not just predicting who's at risk of leaving, you're predicting how much revenue you'll get if they stay. Third use case, fraud detection. Here I ask the agent to build a binary classifier for the fraud flag, handle the class imbalance, focus on metrics like precision and recall for the fraud class, and create a risk score we could use to flag suspicious accounts for review. The agent might use a tree-based model, it computes a confusion matrix, and so on. In a real environment, this could feed into a queue for analysts or into automated rules to hold or block high-risk transactions. The business value is that this is a straightforward path from raw behavioral data to loss prevention and operational efficiency. To wrap up, I asked the agent to create a summary table across the three models, highlight the key metrics, and explain what each model means in business language. This is exactly what you'd bring to a VP of sales, a CFO, or a risk leader. Which levers can we pull? How reliable are these predictions? And what's the expected value if we act on them? Because everything we did from schema creation to exploratory data analysis to modeling happened inside Databricks on governed tables, you can take these same notebooks and productionize them, schedule them, or embed them into downstream dashboards and applications. What makes the Databricks Data Science Agent Assistant special is that it's embedded in your data platform. It sees your Unity catalog, respects your permissions, runs on your clusters, and outputs artifacts that are ready for production. It doesn't replace data scientists or engineers. It amplifies them, turning repetitive work into prompts and letting you spend more time on what actually matters, framing the problem correctly, validating results, and partnering with the business on decisions. Thanks for watching, and please subscribe if you like this video.